few types of role for your formal method in software engineering. One is will be formal specification. Another one will be formal verification. And then after that, for our Z, because we are going to use Z language, okay, so this Z language falls under model-based approach, okay, or model-oriented approach. So you have also property-based or property-oriented approach. Okay, so in each approach you can have sequential, concurrent, and so on. But for our Z, okay, language, Z language, it will be sequential model-based approach. Sequential means step by step. Means you must show one by one to proceed with another. Okay, so that's what we call as sequential. Okay, so we are going to use one formal language for our language for our formal method. Okay, for this course. Okay, so we are not going to concentrate with others because there are others. So we don't have time to teach most of formal method to you. So I will just select one formal method we call as Z here. Okay, to proceed with our assignment, tutorial, and also for you to answer during the final exam. Okay, so let's look at chapter 2 here, okay, where under this chapter, there are also parts where you are going to do some revision related to what you have previously learned in your set theory, discrete maths, and so on. Okay, so gradually from chapter 2 onwards, okay, I will introduce also some of the symbols that you may or may not have used before. Okay, so how to use these symbols in our Z specification language later. Okay, before we can proceed, before that, okay, introduction of Z specification language. So under this chapter, you are going to learn about what is actually Z language itself, and then what are the fundamental concepts that we are going to use in our Z language. Okay, how to declare types and also variable, and after that we are going to proceed with what we call as Z schema. Okay, so these are actually the, how to say, the basic, okay, information about Z language. Everything under chapter 2 will be related to basic specification language, basic Z language. Okay, so as I said to you, Z, that is actually the pronunciation of our language today. Okay, Z, okay, actually it's actually old language, formal method, a very old formal method language. Okay, and of course from Monday we say that when we talk about formal method, we are talking about mathematical notation, mathematical text, anything related to mathematics, okay, mathematics symbols and so on. Okay, so same thing for Z here because it is one of formal methods, okay, but the main purpose of Z here is as specification language, where you use it to specify the requirements. Okay, you are not going to use Z for verification. Okay, because that one is you can use other languages to do verification. But for our Z here is more on the specification language. Okay, more on the specification language. So when we talk about mathematical notation inside our Z, of course, you are going to use set theory, something like member of, not a member of, union, not intersection, and so on. All these you can use later in your Z schema, okay, using Z language. Okay, so also logic, okay, not equals to, equal, less than, greater than, all those things are actually you can use later inside your Z schema. Okay, so actually the name of this Z actually comes from Zermelo. So from this person who actually started with the language, so they call this as Z. Okay, so you can see it's actually starting in 1977, very old formal method, but it's actually in terms of, if you compare, okay, one of the popular, okay, formal method, okay, one of the popular form, even though it is old formal methods, but it is one of the popular formal method. Okay, so as I told you also on Monday, Z falls under model-based approach or notation or design and so on. So why we say model-based? Because later you are going to model states. Okay, the first thing that you are going to model, the first states that you are going to model, we call as state space schema. After that will be initial state. Then after that will be operation states, and then after that will be error scenarios, and the last part will be complete schema. All these I will gradually explain to you on how to do all these states. Okay, so when we talk about Z language, it is model based, so we are going to represent states here. Okay, so inside the states you will have variable declaration. Also you will have what we call as condition, constraints and so on. Okay, something like precondition. Before you can proceed, what is the precondition that you have to check? Okay, so all these will be inside your states. Okay, inside your states. Also, one of the parts here is operation of function. So normally in our Z schema we call as operation schema. Okay, the way to write will be similar to your state space, just that the information inside there will be slightly different, because for the operation schema, you are talking about your function. What do you want to do with that? Similar like in your programming, let's say C or C++ that you learned last time, you have function, right? Okay, let's say you have add function. So what is the purpose of add function? Is to add, right? So when you want to add, what are the things that you want to do to add the data? Okay, so there will be formula, there will be input, there will be output and so on. So that is operation state, operation schema that we call as operation schema. Okay, so we are going to do all these things, okay, from beginning, from this week onwards, okay, where you, of course, if you have gone through the practical session where you have select your assignment group and so on, you will start with your title, operations module and so on. But by next week, most probably you have to start with your Z already. Okay, so from there you will see the step by step also on how to start your Z. Okay, so all these are actually something like these are possible states. Okay, normally anything states that you want to do here, initial states, and then also changes and queries. And normally these two will be related to operation or function. Okay, the last two here, state changes and state queries, normally about your operation. Possible states here, you can have error scenarios. You can have also states where you do separate state. Okay, where you do separate states in a state space to make it, how to say, let's say you have module, one module, but when you want to do for that module, it's a very big module. So you can split your module into smaller module. Okay, so all these you actually can do in your assignment later. Okay, so we are going to use what we call as a graphical construction later for our Z language. We call that graphical picture or graphical construction as schema. So that's why later you will see that I will just say as Z schema, Z schema, Z schema, because Z schema is the one that graphical construction of how we are going to represent our specification later. Okay, so inside the Z schema here, okay, you can show your state spaces now. You can show initial state, you can show operations and so on using the same symbol. Okay, the same symbol, we call that symbol as schema. Okay, easier compared to just write lines of statements without separation. So we use graphical construction to separate parts. The above part normally will be declaration. The below part will be more on the predicates parts or the constraints or the condition and so on, where you have for your system. Okay, so we call that as schema. So that's why later I will show you what does the schema, Z schema looks like. Okay, the diagram for it. Okay, so just now is about Z, so it's general about Z. So when or what you are going to do later, okay, inside your Z specification language, Z language, we are going to use a lot of set theory inside here. For example, union, member of, not a member of, intersection, whatever. Also logic, less than, greater than. And then you may have other things. For example, some of you want to do quantifiers. There exists for all quantifiers, set comprehension. All these are actually related to set. Okay, so everything that you have learned before, okay, whatever that you have learned in your discrete maths last time, you may have to recap whatever that you have learned, because there are sometimes how to write those statements. Even though last time you put number, right? Normally when mathematics you use number, 20 or whatever numbers. But in our Z language later, because we are going to specify the system, our system. So we are not going to use a lot of numbers here. We are going to use a lot of variables. Okay, similar like programming, you use variable to represent your data. So same thing here, you are going to use variable. But these variables, you are going to define those variables as set. So this is where later you are going to look into what we call as type. Okay, data type in your Z and so on. Okay, so everything in Z is set. For now, you have to remember what is a set. Means that all your data will be put inside curly braces. Those are set. Okay, but the data inside the set cannot be duplicated. Okay, remember that cannot be duplicated. So let's say, okay, let's say you want to say that student name in our campus. Student, all the students in our campus, there may be a few students with the same name. So in your database, okay, because Z is actually according to set, you have to put only one name. Let's say you have 10 students with the same name, but in our database will be one name only, even though it is 10 students. Okay, so because in set, you cannot duplicate the data. Remember that, even though last time you learned set, no duplication is allowed. For now, you learn set, general set, no duplication is allowed. And then for our Z, when we talk about set here, capital letter, small letter are two different things. Okay, even though one character only different, one is small letter, one is capital letter, is two different data already. Okay, so remember that when we talk about set in our Z, different small letter, capital letter, with number or without number are two different things already. Okay, so remember that. Okay, because this thing, why I stress out that set cannot be duplicated, for example, because when we do in our Z schema later, we are going to have what we call as relationship. Okay, so something like you learn, for example, let's say relation or function in your discrete maths. You have domain, you have first coordinates and second coordinates, x and y, for example. You link these two together. So because the data are actually cannot duplicated, so your arrow or your link can be many to this area. Okay, because even though you have one name, but you may have 10 students with the same name. Okay, so that is how we are going to think later how to link your data in your Z later. Okay, so remember Z for now, we are going to use only set for now. Later in advanced or extended structure for Z, you are going to have other things also. But for now, starting with Z, we are going to start with set, where no duplication of data inside your set. Okay, that's why here no ambiguity, distinguishable, and so on. These are the actual meaning why you don't have duplicate. Okay, and then in set, of course, whatever the data inside your set, we call as element or member. Okay, but in our Z schema, gradually when we do our operation schema, whatever, I will just say that is the data exists in your database or not. The word exists here means that is it a member of or an element of your data inside the database. So another term that later I will use in our Z will be exist or not exist for elements of member. Okay, so you will hear me, does that data exist or not? Okay, when I say exist here, means that the symbols that you are going to use here will be either member of or not a member of symbol of your set. Okay? So, okay. So, that one I will show you the symbol, set symbol that we are going to use, starting to use in our Z. Okay. One thing that you have to know, the first symbol that you are going to see, okay, will be double equal. Double equal, Double equal here is not comparison symbol. In your programming, right, you put double equal means compare. Left hand side is equal to right hand side, or this data is equal to this result or not, okay? Comparison, but not in Z. Don't use double equal for comparison. Double equal means define as. So what does define as means? Actually, if let's say you have one variable, you want to say that these are the data inside your variable there. Okay, assuming like your table database you have table customer, you have all the customer name inside the database, right? Assuming so you want to say that customer equal curly braces, then you put all the list of customer there. So equals means define as. Okay, equal means define as. So it's not comparison. Because I know some of you, when you start doing operation schema, you want to compare left hand side with right hand side, then you put double equal. Wrong. When you put double equal means you define left hand side is actually these are the data for this one. But no, what we want to do is we want to compare, not define the data. Okay, different So double equal only used for define as. Okay, define as. So for example here, I want to say that ocean here is defined as 4 data here. Only 4 data for ocean, for example. Okay, so I just put double equal, then curly braces set. Set, curly braces, then these are the data involved in the ocean, means the data inside the ocean there. Okay, same thing for this one, odds, for example. Okay, colors. Let's say in my records, I may have 2 yellow color. Okay, 2 yellow colors. So does not mean that here I put another comma, put yellow, cannot. Okay, set must be singular only. It means 1 only. Okay, cannot duplicate. So if let's say you have 2 data, yellow 2 data in your database, but the way to write in your set is using 1 only. Okay, no duplication is allowed. Okay, meaning that for my colors here, okay, I will have red, green, blue, yellow. Okay, so means that only these 4 colors inside my database. I don't have other colors, but I can have other data with 2 yellow color, 3 green, 3 green color. Okay, and then maybe 10 blue colors, for example. Doesn't matter. But in my color here, I have 4 type only, 4 data only. Okay, so meaning that I cannot duplicate the data. Yeah, for now, no, for set cannot duplicate the data. Okay, later in future in the chapter 4 and 5, you will see you can do some duplication. But for now, no duplication for your set. Okay, so now, just now I say that when we do set, okay, we are going to deal with members of elements of our set. So it means that I want to say that red exists or not in my colors or not, for example. So I want to say that. So I need to use member of symbol. Okay, the E symbol. I think all of you have seen this symbol. So this is member of. Okay, so if the member does not exist, then you put this symbol, not a member of. So in terms of set, we call as member of or element of, or not a member of or not element of. But later, when you do your operation schema, you can say that exists in your database or does not exist in your database using the same symbol. Okay? So you can say member of is not wrong to say, is it a member of this? Yes or no, something like that. So for normally this symbol is actually for you to do precondition, means checking before you can proceed. Okay, this symbol, member of, not a member of, is for you to check whether the data exists or not exists in the system. For example, I have customer just now, right, in my database. Then I want to add a new customer into my database. Okay, I want to add a new customer in my database. What happened? I don't want to duplicate the data because set cannot be duplicated. So I have to do checking. So I need to check that whether the customer that I want to add here exists or not in my whole database. So how to show that? You can use this symbol. Okay, I want to check whether exists or not exists in my database. So the symbol that I can use will be not a member of or a member of. Understand or not? Okay, for example, okay, let me show you using Microsoft Word. Okay, I haven't installed. For those who have Microsoft Word, you can install this. I just want to show you. Okay, if you install this, I will show you just a few seconds only. Okay. So when you open your Microsoft Word, okay, so you enable content, then you will see. If you must enable content, if you did not enable content, the Z here, when you click Z here, this is Z word tools, it will be empty here. It will be empty if you didn't enable the content. You must enable the content to see the symbol. Okay, for those who have not installed, let's say you see that why need to install, it's up to you. It's not compulsory for you to install. You can use Z editor, Z GitHub editor to do the assignment later. Okay. This one is normally in the class tutorial or lecture. I will use this to show you how to explain some of the things here. Okay, example, just now I have customer. Okay, normally I like to use some more letter. So I will do like this, right? So let's say in my customer I have the name is A. Okay, whatever lah, the name, this is our customer name, cannot duplicate. Okay, let's say these are our customers in the database. The arrangement is not important in the set. Remember, the arrangement is not important in the set. So you can jumble up the answer there. No need to be in order. Okay, but cannot be duplicated. I cannot add one more here. I cannot add one more here. B, cannot. Because already B exists here, I cannot have this. Okay, so I have to remove this. And I have. Assuming these are my customer data in my database data. So actually, when I show you or when I do explanation in the database, normally I just draw table lah. Table lah, like this . Assuming this is my customer table. My customer table So I will have A, small letter, A, B, W, inside my table, assuming this is my table. Okay, assuming this is my table. Now I will just use table like this to show the data in my database. Assuming this is my database table, these are the data stored in my database. Okay, for my customer. Okay. So now, when you want to do operation in your Z later, one of the operation, remember when you write program, whenever you want to add a new customer. Okay, assuming that you want to add a new customer. So for set, the data cannot be duplicate, right? Data cannot be duplicate. So how to show that? Okay, let's say my new data, new customer, is equals to S. Okay, that I want to add. My new customer is equals to S. Okay, doesn't matter lah what is the name here. I just say S here. This is my new customer. Okay, so in order for me to make sure that I can add this customer into my database, I have to make sure that this customer does not exist yet in my database, right? Or exist or does not exist? If I want to add this customer here.
Does not exist.
Does not exist, right? So how to show that does not exist? Okay, I need to put, okay, let's say S here does not exist, then I use not a member of in my customer. Sorry, S is our data. This one. This is my variable. Assuming this is my variable. Alright. So means that I am checking whether the new customer that I want to add, okay, exists or not in my database. Okay, in order for me to make sure that adding new customer in database is successful, okay, so my condition is cannot exist yet. Correct or not? If not successful means exist already lah. So if not, if success means the customer that I want to add cannot exist yet. Okay, cannot exist. So that's why I am using not a member of. Okay, not a member of. But in this scenario, my new customer is S. So I saw from your check, I have S. So means that I cannot add this customer in the database because already exists. So this is where later you learn to put error message and so on lah. Similar like you did in your programming. Okay? So if let's say my new customer is R, for example. Okay, is my new customer is R, then I check. A, not B, not W, not G, no. Not exist yet. So, not exist, okay. So, means that if not exist, then I can add R into my database. Okay. So, that is actually how you do later using your set symbol. Okay, for now, it's membership symbol lah. Okay, for example, this is how you do it. So, member, not a member, is actually, we normally do to check. For checking, we call as precondition. Checking whether exists or not exists in our database. Okay, so that is actually this symbol. Okay, okay. If let's say this one is adding, assuming that I want to update. Okay, I want to update some information about the customer. Maybe the age. Before this, I accidentally key in 12. Should be 21, for example. Accidentally key in 12. But actually the age should be 21. So, in order for me to update, the customer must exist, right, in my database. So, if that is a scenario, because I want to say that must exist, rather than you put not a member, then you change to a member of. Means that exists in our database. Okay, so that is actually how you think, similar like how you think in terms of programming, but you translate that sentences using set symbol. Okay, so that is one of the things about member of and not a member of. Okay, up to here, can So, of course, I didn't explain to you the whole thing yet. Just that how you can use this symbol later. Okay. So, the next one. Okay. Empty set. Okay, empty set here. So, normally in your discrete maths, whatever that you learned last time, opening, closing, curly braces, also empty set. Okay, opening and closing curly braces also will be empty set. But for our set schema, we are not going to use that opening, closing. Okay, we are going to use only one symbol here, empty set like this. Also, you have seen this one before lah. Empty set means empty lah, nothing inside that. So normally, empty set is used a lot in your initial state later. Okay, before you start anything, you have to tell that you don't have any data at all inside your database. So how to say that no data at all means by using empty set. Okay, by using empty set. So normally you use at the starting of your Z lah. Starting of your Z later. Okay? So, we are going to use this one only for empty set. Opening, closing curly braces. We are not going to use that in our Z schema. Okay. You may have singleton set, but seldom we have. Singleton means you have only one data. This is what we call as singleton. Okay, so singleton seldom we have in our schema, but you may have cases where you need to do singleton where you have one data only. One data only. So, you may have, you may not have. Okay, just to say that you can have singleton data. Singleton data means you have one data only. Not empty set. Okay, it's not empty set. Empty set means nothing. You have one data only inside there. Okay, that is what we call as singleton set. Okay. Okay, the next one. I think you have seen this symbol before. Subset. You know it's subset, right? Okay, but for our Z schema, you have two symbols. Subset. Another one is proper subset. Two different things. In maths, you use this with a line below. Is the same meaning as this without the line. But for Z is two different meaning. Okay, what it means by this? If you have the line here, we call it a subset only, meaning that if you have two record of two database, okay, let's say two record. One is customer 1, one is customer 2 database. So you have the record here. This data, if you put subset of, let's say customer 1 is a subset of customer 2, you can have, let's say customer 1, you have 5 record, customer 2, you have 10 records. So 5 record here is actually the same as 5 record here. Out of 10 lah. So you can put subset. Okay? So you can have that. Also, subset here means that I have 10 records here, customer 1. I have 10 records of customer 2 here. Both are the same. Then this one also we call as subset. Okay? Means you can have up to the same between customer 1 and customer 2. So that is subset. So you have equal here. Something like equal down here. But if let's say your scenario, customer 1 cannot be at all same as customer 2. Cannot be the same at all. The data, of course the data exists all inside customer 2. Just that total here, let's say you have 5 here, 10 here, okay, but you have 10 here, 10 here, cannot use. Proper subset, cannot use. Proper subset means less than. Means that here, customer 1 can have maximum 9 records only. Understand? Cannot be equal at all with customer 2. But the data can be the same lah. But only missing maximum, not the same. Let's say here 9 records, here 10 records. That's all. That is the maximum. Cannot have 10, 10. If 10, 10, automatically you have to use subset already. Okay, subset already. So these two symbols, okay, you will see later in our tutorial also, but I just explain to you just for understanding. It's actually, for example, let's say, what is the tutorial? Okay, let's say in the hospital, if I'm not mistaken, hospital. In the hospital there you have a bed, right? Those who are actually going to occupy, patient who are going to occupy the bed. Let's say in the hospital we have 100 bed. Okay, 100 bed in the hospital. Okay, and then the patient who can occupy the bed maximum can be 100, right? Right, because we have 100 bed. Patient who can occupy the bed maximum will be 100 also. Okay, but if let's say all the bed are occupied, means 100 bed are actually occupied by the patients. Okay, tak ada kosong, no empty bed. So if let's say you are a new patient, you have to be actually you need to occupy the bed, but because the bed are all full, no empty bed, then I put your name in the waiting list. Okay, waiting list. So your name will be in the waiting list. Okay, so the waiting list exists only if the bed are full. Right, total bed are full, means use all bed. Okay, so now, let's say now, after I check, after a few days, then I check. The bed now only 90 patients occupy the bed. occupy the bed, right? 90 patient occupy the bed. So left with 10 empty bed, right? 10 empty bed. So if you have 10 empty bed, what happened to the waiting list just now? What do you think? What do you think happened to the waiting list just now? If you have 10 empty bed in your system, what happened to the waiting list here? What do you think? Is there anybody inside the waiting list or not? What do you think? No, right? Because waiting list exists because of the bed full. But if the bed got empty bed, okay, 10 empty bed, confirm nobody inside the waiting list. So, what I want to say here, in order for you to indicate that nobody inside the waiting list, then you can use proper subset. If, okay, patient, okay, is actually lesser than total bed, okay, patient who occupy the bed is lesser than total bed, lesser subset, proper subset, means that you have a few empty bed, implies that or telling us that waiting list shouldn't be anybody inside the waiting list. Okay, so in order for you to prove that nobody on the waiting list, so you can see that patient who occupy the bed cannot be equal at all with the total bed. Then you have empty bed, at least one empty bed, confirm nobody inside the waiting list. Okay, because if let's say you have 20 inside the waiting list, now one patient discharge, then you take one, still got empty list, so means you full the bed. But there is one time where 10 patient goes out, you left with 10, but here only one patient in the waiting list, so you put one, so left is 9. So no more patient inside the waiting list. So means that our waiting list is empty. Understand or not? Can see? Blur. Can see clearly or not? Okay, I try to write using scenario here. Let's say bed, just now scenario, I have 100 bed. Okay, for now, occupy patient who occupy, patient here is actually those who occupy the bed, equals to 100 also. Means full, but now I have 3 extra patient can occupy because already full. I have waiting patient 3. Yeah. So, okay, if let's say you have patient, okay, patient. For example, for example, I put like this, easier for you to understand, okay. Normally, this one, let's say you have 100. So this is actually normally you use subset later, okay. When you write your declaration, nanti you use subset, okay. But if let's say you have P less than P, okay, patient who occupy the bed is less than P. So normally this one you use proper subset. Yeah, use proper subset. So I use like this to show what symbol that you have to use later. So this one we can see that this is where you say that implies this is implies that waiting equals to 0. Okay, waiting equals to 0. Because if let's say patient who occupy the bed is lesser than total bed. Let's say you say 90 patient only occupy the bed. Okay, total bed is 100. Now patient is 90. So you have 10 empty bed. Okay, so confirm nobody inside the waiting list. If you have somebody inside the waiting list, you ask that patient to occupy the bed. Okay. So increase 91 here, maybe if you have 3 become 2. Then another one. Here 8, leave left with 1. Then here left with 7. Here nobody. So still less than this one. Okay, so means that waiting list at the end will be 0. Okay, so that's what I mean by this. So this one you are not going to use now. Just that you have to understand the concept of using about subset and proper subset. So now you have a few symbols to understand, okay? Okay, the next one is power set. Okay, I think all of you have heard about power set. Okay, in our Z schema, power set means 0, 1, or many records of data. Okay, 0, 1, or many records of data. That's what you mean by our Z. In mathematics, you have combination. But for us, when you put power set, we are talking about 0 data, empty data lah. Okay, empty set, or 1 data, 1 record only, or many records. That's what it means by power set. Okay, another translation related to Z. Mathematics, you have possible combination of elements. That is mathematics term. But when you want to translate later into your Z schema, power set here means either empty set, no record at all, or you have 1 record of data, or you have many records of data. Okay, so that's what I mean by power set. So for power set here, normally, let's say you store in database just now, okay, you don't really consider the size of your database. Can be extend. You don't consider the size. No fixed capacity. Okay, that is what we call as power set. You don't consider, oh, my database can occupy 100 only. No, you don't consider that. You can go beyond that. That is power set. Okay, that is power set. So when you do your Z later, I will ask you how many records that you want to save inside your database. Are you going to save 1 record only, or you are going to save many records? Okay, okay, so if let's say you want to save many records, and then those records or the size, you don't care. You don't say whether 50 records only, 100, 1000, you don't care. If you have that, then I will consider you to go for power set. Okay, for example, let's say I have the customer here, right? But of course here I didn't use, this one is not the type yet. Let's say later I will explain to you also about type. Let's say my type now is customer. Later I will show you how to do this, but don't worry about that. Okay, this is my basic type now. Okay, so I want to say that my customer database, I want to have more than 1 customers in my database. The data of my customer is exceed more than 1. So I just do like this. This is what we call as variable declaration. Later I will show you. I will put power set. Then I will put customer. Okay. So when I do this line, C small letter. When I do this statement, I am telling people that I will have a database, okay, that is called customer. This one, a database to represent customer, small letter, okay, where the data there will have many customers' data when I put power set. Okay, in my database, I will have a variable that will communicate with database here called customer, small letter here, where inside my database there, I will have many records of customers. Okay, when I put power set. If I remove this one, power set, it means that I will have a variable called customer that will communicate with my database also, but my database only can have 1 single customer only. So that's wrong because database can have many. So I have 1, cannot, something wrong with it. So that's why you have to put power set. Okay, to show you can have many records. Because here, let's say I just show that database here, right? This is my database. I have many records. In order for me to say that this is many records, then I put power set here. Okay, I put power set here. Okay, so remember just now, this is, don't show the size. I can have as many as I want in my database. Okay, but of course, if let's say database. Let's say this room, this is to say DK4, I can have only 150 students only in this room. Fix, fix. I cannot have 162 or 151 also because the seats is 150. For example, so fix 150. So if you know exactly the size of your record, the size of your database there, you can change your power set just now to finite set here. This one, change to finite set F. P for power set, F for finite set. Finite set means you know exactly how many records that you are going to have. But finite set and power set will be similar. The difference is only the size. Finite means you know the exact size or the exact value of the size of the record, whatever. For power set, you don't really know. You can put as many as you want. Okay, so normally for me, because I'm so lazy to think, the size, I normally just put power set. Okay, so general, easier, just power set. Except, you know, like there's exercise like in aeroplane or room, classroom size, that is where you have exact, then you can put finite set. Okay, so these two are similar. The only difference is in terms of the size only. Okay, so that is finite set and also power set. Okay, so when you have finite set or power set, sometimes I will ask you, how many records do you have? How many customers do you have in your database? Then you cannot open your database, 1, 2, 3, 4, 5. No, you don't have to do that. Okay, in your Z schema, you don't have to do that. What you can do is, you can use what we call as cardinality symbol. In your discrete maths, you use double bar. Remember? The double bar, you have the middle variable inside there. Double bar to know the size. But here we don't use that symbol. We use hashtag symbol. Okay? Hashtag symbol is used to know how many records do you have. Okay? How many records do you have? So for example, the customer just now, right? Go back to the customer here. Let's say I have, this is my customer just now. I put down. Okay. I just put down here to show my customer here. These are my records of the customer. Okay. So I put, for example, let's say I want to know total customer. Okay. So I want to know how many total customer. Okay. So how to do that? Okay. I use this variable. Let's say this is my variable. Later we can do variable declaration. Here I didn't show you the variable declaration yet. Equals to, okay, if my variable here is integer, you don't have to use hashtag. But now my variable is customer. Then what I need to do is I just put hashtag and then customer. No space, like that. Just do this. So when I use hashtag customer, the result will be total. So record, let's say my customer here, I have 1, 2, 3, 4, 5, 6, 7. Then the result that I will get will be 7 as the answer. Okay, it will be a number. Thought I will have 7 records of customer in my database. Okay, so you just use hashtag symbol. Okay, hashtag symbol. So hashtag symbol only used for type like this, for type like this, But if your variable declaration later is integer, n or z, later you will see what is n, what is z, n or z, straight away you put equal without hashtag because the result is only integer data. Here, because the type is customer, you have to put hashtags because it's different type lah. One is we call as basic type. One, the output is integer. So similar like you do casting lah. Remember casting, right? To convert your string to integer, for example, you do casting, right? So something like that. You do casting. Here we don't do casting. We do hashtag only. Okay, hashtag is to convert the data from whatever the type into integer. Okay, so that is okay, cardinality. Okay. Any question until here? Okay. Cardinality just now is to find records. So the one that I show you just now, N or Z, those are what we call as infinite set. So infinite set is a given set, means that built-in set where you don't have to define again. It's already given to you, you can just use it. In our Z schema, remember, in our Z schema, because we are using SPI VZ, okay, we call as SPI VZ, the one that we are using is called as SPI VZ, okay, you can only use N and Z. You cannot use Q, R, A, whatever, cannot. So your data that you want to represent later must all be integer only. Cannot have decimal. Even though you say price of your product is RM2.99, cannot. You just put RM3. Okay? So you cannot have decimal points. Okay, means integer. So it's either N or Z. If N means 0 onwards, means positive, 0, 1, 2, 3, 4, 5, and so on. Z means positive or negative. Okay, but if let's say you will have also we call as N1. N1 means 1, 2, 3, 4, 5, 6 without 0. Okay, so if you see Microsoft Word just now, here, this is the numbers here. You have Z, 0, a positive and negative number, N, 0, 1, 2, 3, 4, 5. And if let's say your data cannot be 0 at all, must be 1 onwards, then you put N1. Let's say when you want to buy things, right? Okay, if you want to buy things, the price cannot be 0 at all. If you add new item into your system, the price cannot be 0. How to sell things if the price is 0? So means that the data will be N1. Okay, so you can use N1 here. QRA, make sure that this data or this type does not exist in your assignment or tutorial, whatever. Only Z, N or N1 only should exist there. Okay? Understand? This one. So later also I will show you how to do this. Okay. Any question at here? Or you want to take a few minutes break? Okay lah, we take a few minutes break. For those who have not signed in the attendance, X6